Hello everyone, welcome to Vyas Certification Kota. In this session, we are going to discuss all NCERT and exercise solutions of class 12 chapter number 8 electromagnetic waves. Clear? So, in this session, you will find detailed video solution of each and every question, as well as you will find some key concept behind that question also. Clear? So, now we are going to start. Concentrate on a screen. Now dear student, we are going to discuss this question, and this question is asked, actually this question is 8 point number 1, clear. In this question it is given to you, figure shows a capacitor made of two circular plate, each of radius 12 centimeter, clear. So we can see, if we talk about radius, so radius is given to you r. This is equal to 12 centimeter. We can convert into meter. So 12 into 10 to the power minus 2 meter. Clear to everyone? Yes. And it is separated by a distance 5 mm. So we can say this separation distance is given to you. This is 5 mm. Clear? So from here you can say, let's suppose this is D and this value is 5 mm and this is equal to 5 into 10 to the power minus 3 meter. Clear to everyone? Yes. Now, it is also given the capacitor is being charged by an external source, and that external source is not shown in a figure. The charge current, or we can say the charging current, is constant, and this is equal to 0.15. Now, we can say outside this capacitor, whatever we have current, this current is known as conduction current, and outside this capacitor displacement current is 0. And what about total current? So we can say inside, or we can say between the parallel plate capacitor, we have displacement current, and in this region conduction current is 0. But we know this current is constant, IC equal to ID. So this value is given to you, I equal to 0.15 ampere. So from here we can write like this, value of I, this is 0.15 ampere. Clear to everyone? Now what is our objective in this question? Our objective in this question is to calculate capacitance and the rate of change of potential difference between plates. Clear? So now we know, we can see, yes, we know value of capacitance. Now we know that if we have parallel plate capacitor and between these parallel plates if air is included, at the time we can say capacitance value is given by epsilon naught A by D. Clear? So from here we can say this is given by epsilon naught A by D. Clear? Now what is value of epsilon naught? This is equal to 8.85 into 10 to the power minus 12 multiply. What about area? Radius of circular plate is given, and so we can say this is pi into r square, means 12 into 10 to the power minus 2 whole square divided by, we can say D. D means we can say this is distance between parallel plate capacitor. So this is equal to 5 multiply 10 to the power minus 3 meter. Clear? So from here we can say this is equal to 8.85 into pi multiply, we can say 144 into 10 to the power minus 4. 8.85 into pi multiply 144 into 10 to the power minus 4 into 10 to the power minus 12, and it is divided by, we can say 5 into 10 to the power minus 3. Clear to everyone? 8.85 multiply pi multiply 144 into 10 to the power minus 4 and this one. From here you can say this one is cancelled out, this is 10 to the power minus 1. Clear? So we can say value of capacitance C, this is given by 8.85 multiply pi, clear, we can say 144 into 10 to the power minus 13, and it is divided by 5. Clear? So if you find here, if you solve it, you can say this is 1, we have 7, and again we have 7, 1.77 pi into 144 into 10 to the power minus 3. So from here you can say, let's suppose if you assume this pi is near about 3. Clear? So we can write like this, this is 21, we have 2, this is 23, we have 2, so 3 multiply 2, this is 5.31. Clear? 5.31 multiply 144 into 10 to the power minus 13. Clear? And this value we have in farad. Clear? So now if you multiply 5.31 with 144, so near about, if we take this is 5.5, so 5.5 means we can say this is 11. This is 11 divided by 2, near about. clear. So 11 divided by 2 multiply 144 into 10 to the power minus 13, clear. So from here we can say value of C, this is given, this is 4, we have 4, 8, 4, 1, 5, 8, 4 divided by 2 into 10 to the power minus 13, clear. So value of C, this is given 7, we have 1, we have 9, 2, clear. 792 into 10 to the power minus 13, clear. So from here you can see this C is near about, this is 80 into 10 to the power minus 12, and because this is capacitance, capacitance value we find in farad, clear. So C value is, we are getting, this is 80 picofarad, clear. So this is what, this is value of capacitance of this capacitor, clear. Now listen carefully. In this question we have one more part of A, that what is value of rate of change of potential difference between plate, clear. So from here we can see if we want to find rate of potential difference, just a minute, I am writing this value in this side because this will be useful for us for next parts, clear. Yes, so from here we can say actually we know Q is equal to what, CV, clear. So if we differentiate this charge Q with respect to time t, we can say this is given by C dV by dt, clear. So from here can we calculate value of dV by dt? Yes. So dV by dt, this is given by dQ by dt, dQ by dt is equal to what? We can say this is rate of charge. So we can say this is equal to what? Current divided by capacitance, clear. Value of current is given in this question 0.15 divided by value of capacitance, this is equal to 80 multiply 10 to the power minus 12, clear. So from here you can see this is equal to 15 by 100 into 80 into 10 to the power 12, clear. 1, 2, 3, we can say this is 10 to the power 9, clear. So from here we can write like this, this is given by this is 1 point, now we have 7, so we can say 1.8 into 10 to the power 9, and this is volt per, we can say second, clear. So this is answer of rate of change of potential difference between plates, clear to everyone? Yes. Now we are going to discuss part number B, clear. So now concentrate, part number B. Clear. So actually I am writing here value of C, this is 80 picofarad, clear. Now part number B is given to you, obtain the displacement current across the plates, clear. So this is very easy, we can say displacement current is equal to conduction current, and this value we have equal to 0.15 ampere, clear. Outside this parallel plate capacitor we have only conduction current, and between this parallel plate capacitor we have displacement current, clear. But if we talk about magnitude, magnitude is same, and we can say IC equal to ID, this is equal to 0.15 ampere, clear. So we can say A and B completed. Now we are going to discuss part number C. In part number C it is given, is Kirchhoff's first rule, or we can say junction law, it is valid at each plate of the capacitor, explain. Now listen carefully. Now you can see if we talk about this parallel plate capacitor, now incoming current is equal to what? This is conduction current, clear, and here we are having displacement current 0, and what is outgoing current? Outgoing current we can say this is equal to ID, and ID is having same magnitude as IC. It means we can say incoming current is equal to outgoing current for this parallel plate, clear, or we can say IC equal to ID. It means we can say yes, Kirchhoff junction rule is valid for the each parallel plate capacitor, clear, or each parallel plate, clear. So yes, definitely, so I can say yes, we can apply Kirchhoff junction rule. Kirchhoff junction rule actually based on a conservation of charges. Now you can see here the incoming current, it is equal to outgoing current, so Kirchhoff junction law is valid, clear. So this is all about this question, clear.